Nikki Ramirez, the reporter for today. In this video, I will discuss two topics. First, recognize common isotopes and their uses. Second, represent compounds using chemical formula, structural formula, and models. To begin with, let's discuss first what is isotope. What is isotope? Isotope are members of a family of an element that all have the same number of protons but different numbers of neutrons. The word isotope has been derived from two Greek words, the isis and topos, which further translate to the same place. So the idea behind using this name is that isotopes variants of a single element are found in the same position of periodic table. So who discovered isotopes? In 1913, while explaining the aspects of radioactivity, Frederick Soddy introduced the concept of isotopes. The first stable isotope of neon is discovered by Thomson. So isotopes are said to be either stable isotope or radioactive isotope. So let's define what is the difference between stable and radioactive isotopes. What is radioactive isotope? Radioactive isotope, or also called radioactive nuclide, are any of several species of the same chemical element with different masses, whose nuclei are unstable and dissipate excess energy by spontaneously emitting radiation in the form of alpha, beta, and gamma rays. Some examples are cobalt-60, iodine-131, fluorine-18, and selenium-75. While the stable isotope, or stable nuclide, are isotopes that do not decay radioactively. Some examples are rubidium-85 and rubidium-87, helium-3, xenon-129, and carbon-13. We already defined what is isotope and its types. Now we are going to give more examples of isotopes and give their importance or uses in our daily life. Isotopes can be used in disease diagnosis and treatment. Iodine 131 used to evaluate the activity of thyroid glands. Iodine 125 helps to identify deep vein thrombosis. Selenium-75 used to study the secretion and activity of digestive enzymes. Technetium-99m helps detect brain tumors. Bismuth-213, dysprosium-165, iodine-131, radium-226, and strontium-89 helps and are used in the treatment of cancer. Xenon-133 used in pulmonary lung ventilation and blood flow studies. Thallium-201 used in diagnosis of coronary heart disease and heart muscle depth and location of lymphomas. Rubidium-85 and rubidium-87 are used in mental illness research. Helium-3 and xenon-129 are used in MRI. Carbon-13 used as a tracer. Tracer is a substance that can be used to follow the pathway of that substance through some structure. Isotopes for irradiation of food. Cobalt-60 or cesium-137. This exposure kills a lot of bacteria that cause spoilage so the food stays fresh longer. Isotopes in industry. Plutonium-238, This is the sources of electrical power in spacecraft. I've finally finished discussing our first topic, which is recognizing some common isotopes and their uses. Remember that when we say isotope, this is a family of elements that all have the same number of protons but different numbers of neutrons. It could be either stable or radioactive isotopes. When we say stable isotope, this is the isotopes that do not decay radioactively. Well, when we say radioactive isotopes, their nuclei is unstable and dissipate excess energy, spontaneously emitting radiation in the form of alpha, beta, and gamma rays. And we learn that isotopes can be used in disease diagnosis and treatment, irradiation of food, and industry. Now, let's go on our second topic, which is representing compounds using chemical formula, structural formula, and models. I have reached my second and last topic, which is represent compounds using chemical formulas, structural formulas, and molecular models. To start, I will recall first what is compound based on what I have learned in our previous lesson. What is compound? Compound are composed of atoms of two or more elements chemically united in fixed proportions, can be chemically broken down into elements. An example of compound is water. All of its components are the same, the H2O molecules. It also stated that compounds are classified into two. These are organic compounds and inorganic compounds. Let's define what is the difference between the two. Organic compound. It is a carbon-containing compound, a carbon-carbon bond. It may also contain both carbon and hydrogen atom. The two atoms of C and H also bond with another elements such oxygen and nitrogen. It is usually large and complex like nutrients. While the inorganic compound, it is a compound that generally do not contain carbon or might have carbon but no carbon bond. It does not also contain a carbon and hydrogen bond together. Example, hydrochloric acid, carbon dioxide, and sodium bicarbonate. After I define what is compound and its two classification, let's go now to the main point of this topic. But first, let us define what is the difference between chemical formula, structural formula, and models. The chemical formula of a compound is a symbolic representation of its chemical composition. Chemical formulae provide insight into the elements that constitute the molecules of a compound and also the ratio in which the atoms of these elements combine to form such molecules. For example, the chemical formula of water is H2O. It suggests that two hydrogen atoms combine with one oxygen atom to form one molecule of water. What is structural formula? The structural formula shows how the atoms are arranged and bounded together in a molecular formula of a chemical compound. An example, the table shows the structural formula of acetic acid and ethyl alcohol. Before we define the next term, let us define first the three types of structural formula: the electron dot structural formula, the line bond structural formula, and the condensed structural formula. There are three types of structural formula. First, the electron dot structural formula. It uses dots to represent the electrons involved with the bonding between different atoms. The picture below shows the electron dot structural formula of three compounds: the H2O or water, the NH3 or ammonia, and C2H6O or ethanol. The red dots represent the non-bonding electrons, and the black dots represent the electrons involved in bonding between atoms. Second, the line bond structural formula. The line bond structural formula is a very commonly used representation of structural formula. Like the name suggests, the line bond structural formula uses lines and bonds to show the covalent bonds between atoms. The picture below shows the example of the line bond structural formula of water, ammonia, and ethanol. The red dots represent the non-bonding electrons. The blue line represents the bonds between atoms. Remember that one line is equals to one pair of bonding electrons. Third, the condensed structural formula. It still uses lines between bonded atoms, but is an easier and shorter way to draw the line bond structural formula because it omits the carbon and hydrogen bonds. We can see this when we compare the line bond structural formula with the condensed structural formula. Another example is shown below. Using the two compound, the C4H8 or 1-butene and C4H6O2 or acetic anhydride. What is molecular model? Molecular model are physical models representing molecular architectures of chemical compounds play essential roles in understanding chemistry. The use of molecular models makes it easier to visualize the structures and shapes of atoms and molecules. There are three different molecular models: the skeletal model, the ball and stick model, and the space filling model. There are three different molecular models. First, the skeletal model. A simpler two-dimensional representations of chemical compounds are accomplished using skeletal models. Second, the ball and stick model are three-dimensional models where the atoms are depicted as color-coded balls or spheres specific to different elements. And last, the space-filling model are most realistic, where the atoms are sealed up in size to fill the space between each other. As an example, different molecular models of acetic acid are shown below. After I define the three terms, I will name some compounds and represent them with their chemical formula, structural formula, and molecular models. The compound ethylene and benzene are represented using molecular formula, the structural formula, and their models. Another example of compound, benzene, acetylene, glucose, and ammonia, are represented by their chemical formulas, structural formulas, and models. The structural formula and molecular formula of butane and isobutane. Common compounds such as water, carbon dioxide, oxygen, and carbon monoxide are represented using their models. I've finally finished discussing the topic about representing compound using chemical formula, structural formula, and models. Representing compound using chemical formula, structural formula, and models are important to have a better understanding about its chemical composition, to have a clear sight of how the atoms arrange and bond together, and to make it easier to visualize the structures and shapes of atoms and molecules. I've finally finished discussing my two topics. This is the time when I will say goodbye. I hope you learned something from this video. And remember, as Kuya Kim always said, mag-aral ng mabuti upang buhay ay bumuti. This is Maria Nikki C. Ramirez, signing off.